Linear equations that are parallel to each other will never touch, and they'll have the exact same slope. Linear equations that are perpendicular to each other are going to cross at a perfect right angle, which this picture probably wasn't. But imagine if you were sliding a piece of paper right in, it would be a perfect right angle, that corner right there. Let's take a look at how we see them. If they are parallel and they have the exact same slope, we're going to have the exact same number. So 3/4 and 3/4, or 2 and 2 over 1, which are exactly the same, right? If we have perpendicular slopes, they're going to be the negative reciprocal of each other. So reciprocal, shout out to Tony, who renamed it refliprical for me in 6th grade. And the reciprocal gets flipped upside down, and we also make it negative, or we change the sign, right? So if my first slope was negative 3/4, then the perpendicular slope, we're going to flip it to 4 over 3 and change the sign. So since this one was positive, now it's negative. Perpendicular slopes are always going to multiply to give you -1. So if we notice, when we multiply these, we get -12 over 12, which is -1. Let's just do one more example before we move on. 2/5 turns into -5 over 2. 2, which remember has an over 1, turns into -1 over 2. Yep. If the slopes are not exactly the same and they're not negative reciprocals of each other, then we just say that the lines intersect, or that the slopes are neither parallel nor perpendicular. So here we can see our parallel slopes, 3/4 and 3/4. My lines are going and never touching as they go through space. Perpendicular slope meets at this perfect right angle, and we've got 3/4 and -4 over 3. If we multiply those, we get -1 as our answer. So if we need to compare two equations to see if they're parallel or perpendicular, we're going to start by figuring out their slopes. So on this one, I have got these in not quite standard form, but close to it. So let's get y all by itself on one side. I could write this as -7 plus 4x, or 4x minus 7. I'm going to do that one today. And we'll divide everything by 4 and see what have we got here. So y equals 4 divided by 4 is just 1. So we can write 1x or just x. I'm going to leave this as 7/4. So my slope here is 1. Let's check out my next equation. 8y minus 8x equals -30. I'm going to add 8x to both sides of this. Again, we can write this as 8x minus 30, or -30 plus 8x, whichever way is easier, because 3 plus 2 is the same as 2 plus 3. Dividing every single thing by 8. 8 divided by 8 is 1. And you could just write this as x. You don't have to write 1x. And listen, I don't really care about the y-intercept, so I'm going to leave it as 30 over 8 right now. -30 over 8. So my slope here is also 1. If we've got 1 and 1, 4 over 4 and 8 over 8, which are equal, these are parallel. If we have a slope, an equation, y equals 2/3 x plus 5, any line that's parallel to that is going to have a 2/3 slope. Any line that's perpendicular is going to have a -3 over 2, right? So we flip it, change the sign. The y-intercept does not really matter when we're looking at making a parallel or perpendicular line. Any y-intercept is going to make it parallel or perpendicular if we have these slopes. The one time it does matter is if we made this equation. Like, oh, it's parallel. Oh, it's exactly the same line. So parallel lines never touch, right? But if we have the exact same line, they always touch. So that's the only time the y-intercept is going to matter too much for parallel lines. Otherwise, any y-intercept will still make it parallel or perpendicular. The slope is the important factor. So one more example, -4 is my slope here. So a parallel line will have -4 as well. And a perpendicular line, remember this is 4 over 1, we flip it to 1 over 4 and make it positive. So a perpendicular line is going to have the slope positive 1/4 x plus whatever y-intercept we end up with. So one thing you'll be asked to do is find the equation of a line that's parallel or perpendicular and goes through a specific point. So let's look at how to do these. Since it is parallel, we already know the slope. It's going to be 2/3, the exact same one. But what we don't know is what y-intercept is going to give us, make it so that we go through this point here. So we're going to write our equation, y equals mx plus b. But instead of m, we're going to put back in the slope that we already know it's going to be, so 2/3. Now, we need to figure out what b is, and we don't know what it is yet. So we're going to use this point here. Did I pick my purple? Use this point here, and we're going to plug this in for x and y, and that will tell us what b we need in order to make that true. So let's put in 5 for y and 6 for x, and the rest of our equation is just staying the same. We don't know what b is yet. Okay, now we're gonna, solve, get b all by itself on one side. 2/3 of 6, 6 times 2 is 12. 12 divided by 3 is 4. Ooh, I bet you can see right now what b is. 4 plus something is 5. But just to be safe, we'll subtract on both sides. 1 equals b. So my equation of a line that is parallel and goes through the point 6,5, we're going to use that 2/3 slope, and we're going to plop this b in, plus 1. My final equation should just be an equation, so I should have x and y in it, ready to get solved for another point. All right, so we already looked at, right, -4x plus 5. Let's use that as our slope since we're parallel and we're using the point 1, 3. Y equals -4x plus b. We need to make sure it goes through this point, so we're going to put in these for x and y. 3 and 1. Let's keep going. -4 times 1 is -4. Going to add 4 on both sides of this equation. We've got 7 equals b. So coming back, put it right into your equation. Y equals -4x plus 7. All right. Another way to do these, if you have graph paper, is graph the point 1, 3. Use the slope to find one more point, and then use your ruler, draw it, and just see where it crosses the y-axis. That's going to be great if it's a whole number. If it's a decimal, it's not quite as nice. And make sure you do use a ruler if you do that, because if you draw a little bit of a squiggly line, it's not necessarily going through the right point. So same equations, but now we're going to make perpendicular lines. Are you ready? So to make this perpendicular, the slope has to flip and change sign. So it was positive, now it's negative. All right. Y equals -3/2 x plus, I don't know yet, b. So I'm going to take my point, plug them in, keep everything else the same, and solve for b. All right. -3 times 4 is -12. Divided by 2 is -6. Going to add that 6 to both sides, and we end up with 9 equals my b. Awesome. Sorry, can't draw at the bottom very well. Y equals -3/2 x plus 9. Again, we could have graphed that if we wanted to. Start at 4, 3, use that slope, and see that it goes through 9. But you don't have to. It's easy to do with just algebra, huh? All right, perpendicular to -4. So we're going to flip this slope 1 over 4 and change the sign. It was negative. Now it's positive. All right, so we've got y equals 1/4 x plus b. I don't know what it is yet. I'm going to plug in my 0.43 for x and y. 1/4 of 4. What goes into 4 4 times? Or 4 times 1 is 4. 4 divided by 4 is 1. Oh, I bet you know what this one is. Solving it, 3 minus 1 is 2. So B equals 2. So my final equation, 1/4 x plus 2. All right, we started with a line. We flipped and changed the sign of the slope to get the perpendicular slope. We plugged in a point to figure out what our intercept should have been. Got it?